Hello and welcome to the Learn Electronics India channel. I am Meghna and today we will be learning about voltage, current and resistance, the three main important concepts in electronics. We will also be studying their relationship in a circuit. Let us start off with voltage. We can imagine voltage to be a pressure or a force that pushes the electrons in the source all towards one direction so that energy performs some function such as lighting up a bulb as in this case. So it's a force that pushes the electric charges from one point to another and its unit is volts. Now 1 volt is equivalent to 1 joule of energy per coulomb of charge. So when a work of 1 joule is completed for every coulomb of charge, then the potential difference or the voltage is said to be 1 volt. And we measure the voltage or the potential difference using a voltmeter. So mathematically, we can represent voltage as work done in joules divided by the charge moved in coulomb. Voltage is the difference in electric potential energy per unit charge between 2 points. Let us break this down so that it becomes easier to understand. We call energy as the ability to do work, and potential in English means that something has got the potential or the ability to do work. For example, in this case, we have a battery, and this battery has got the potential to move all the electrons from one point to another point. So that's what we mean by potential. Per unit charge means one charge, and charge is electrons or the negative charge, protons positive charge, and neutrons. In this case, we are mainly dealing with electrons. So 1 coulomb is the unit of charge, and 1 coulomb of charge is nothing but the charge on these many number of electrons. So whatever the charge 6.24 into 10 raised to 18 electrons carry, that amount of charge we call it as 1 coulomb. Now it is easier to understand. So the difference in electric potential means one has higher potential and another one has lower potential. This difference per unit charge between 2 points is called as voltage. For example, if we take a 9 volt battery or if we take a 1.5 volts battery, then for every coulomb of charge, for 1 coulomb of charge, 1.5 joules of work or 1.5 joules of potential energy is being transferred. So suppose in this case, we have the positive terminal and the negative terminal, and the potential difference or the voltage is the difference in potential between this point and this point. And that number is defined by volts. Moving on, we have the current. While volts is considered to be a force that pushes the electrons, this flow of electrons in one direction is called as current, and its unit is ampere. So flow of electric charges or flow of electrons in a conductor per unit time. Time usually here we take it as seconds, so per unit time is called as current. And 1 coulomb per second is defined as ampere. Now let us break this down again. We know that 1 coulomb is 6.24 into 10 raised to 18 electrons, which means 1 ampere is this number of electrons that flow through a point per second. Then the current is said to be 1 ampere. And all these electrons must flow in one direction for current to be induced. And this work of pushing all the electrons towards one direction is done by voltage. We measure current in a circuit using an instrument called as ammeter, and mathematically we can write current to be the amount of charge divided by time. While talking about current, we will mainly be dealing with two types of current, that is DC and AC. DC is also called as direct current and AC is called as alternating current. The name itself is enough to guess the behavior of these types of current. So when direct current, the magnitude will be constant and the current will flow only in one direction. For example, this graph over here, it is a straight line indicating that it is constant and it is flowing in only one direction, that is, it has a positive magnitude. Whereas an alternating current, the direction will change, it will alternate. For example, here it is positive and for the next period it is negative. So for defined periods of time, the alternating current will have a alternating direction and its magnitude will change at every instant of time. So if you consider from this period to this period, at every instant of time, you can see the magnitude increases, it reaches a peak value and then it decreases. Then after this period over here, it reaches the negative wave. So like this, alternating current keeps alternating, whereas direct current, it will have a constant magnitude and only one direction. Coming to the direction of current, electrons always come out of the negative terminal or the terminal lower potential and they move to the positive terminal. This directional flow of electrons was found after the discovery of electrons or the electron theory. Way before this, current was assumed to have a direction and it moved from positive terminal of the battery to the negative terminal of the battery. While both these directions are still considered, in practice, many people consider the direction of current to be the conventional flow of current, that is from positive terminal to negative terminal. If you can look at this image, this arrow mark on the circuit wire, that is the conventional flow of current from positive terminal to negative terminal. Whereas after the discovery of electron, it is found out that electrons will come out of the negative terminal and then they will move into the positive terminal. So this is one important concept about the direction of current. After studying about voltage and current, let us understand what resistance is. So we have learned that a resistor blocks the flow of current and resistance is its ability to oppose the current. So this image clearly explains what it is. Voltage pushes the current and resistance will oppose this flow of current, and that is why there is a small bend over here which indicates that the current is reduced or it is slow only in that particular point. So resistance is the measure of opposition to the current flow, and more the resistance, less the current, and vice versa. Resistance depends on a certain factors, and two such factors are length and the thickness. So the length of the wire, it is directly proportional to the length of the wire, which means as the length of the wire increases, then the resistance also increases. Resistance also depends on the thickness of the conductor or the cross-sectional area, and it is inversely proportional, which means if the thickness of the conductor is less, then the resistance would be more. R is directly proportional to L, which is length of the conductor, and R is inversely proportional to A, that is cross-sectional area. If I combine these two, I can write R is proportional to L by A. Now we remove this proportionality constant by a term called as resistivity, which is represented by rho. So this symbol is called as rho, and R equals rho L by A. This rho we call it as resistivity. Apart from this, resistance also depends on the material of the conductor. There is an important relation between V, I, and R, and it is called as Ohm's law. So V equals I into R is called as Ohm's law, which we will be studying more in detail in the upcoming videos. You can visit our website for more information. See you in the upcoming videos. Thank you.